Starting off, we're going to go to OdinSpector's download page. Link will be down below in the description. And we're going to click Open Source Serializer. From here, we're going to simply click Download, which will give you the OdinSerializer Unity package. You're going to go ahead and right-click it, Open With, and choose another app. We'll be using Unity 2021.3 as it's the current version that we're using for the project, and click OK. Import everything, create a new folder called Plugins, dragging both OdinSerializer and TextMesh Pro into it. Now open the Scenes folder, rename Sample Scene to Dungeon, and create a new scene called MainMenu. Press File, Build Settings, and drag MainMenu into the scenes in Build, making sure that it's an index of 0. Alright, opening our scripts folder, we're going to create two new scripts, one SaveManager and the other MainMenu. Open up our SaveManager. I'm going to fast track it a little bit. Starting with our imports, we're going to be using Unity Engine, OdinSerializer, System.io, SystemsCollections.generic, and Unity Engine.scene management. We're going to create a SaveManager instance, 3 variables, an int, a string, and SaveData, which are current floor with a default of 0, save file name being a default of save the .koala, and save, which we initialize. This is followed by creating getters and setters for both our current floor and save variables. Before using the awake method, we create an instance, making sure to pass into the if statement, don't destroy on load, passing in the SaveManager game object. We have a public Boolean method called hasSaveAvailable, which is a local string variable called path, which is a combination of both application persistent data path and the save file name. It checks if a file doesn't exist, using the path, returning false if so, otherwise returns true. Before continuing with our methods, we're going to scroll down. Here we have two public classes called SaveData and SceneState, making sure to add to both of them a system.serializable attribute. Within the SaveData class, we have two variables, the first being an int called SaveFloor and the second being a list of scene states called scenes. Each of them have their own getters and setters, followed by a constructor, which sets them to their defaults. Within the scene state, we have 3 variables, an int called floor number, a game state called game state, and a map state called map state. They also have their own getters and setters, followed by a constructor, which sets the variables to the parameters given. Scrolling back up, within the public void SaveGame method, we set the save variable's SaveFloor variable to the current floor, followed by creating a local Boolean method called hasScene, which is set to true or false using save.scenes.find, looping through all the available scenes to see if we can find a floor number variable that matches the current floor, making sure it's not null. An if statement is then used, checking if hasScene is true, calling the update scene, passing in save state, else add scene, passing in save state. This is followed by creating a path, combining application.persistent data path and the save file name, a local byte array called SaveJSON, which uses OdinSerializer's serialization utility.serializeValue, passing save, and then setting the data format to JSON, before using file.writeAllBytes, passing in both the path and the local SaveJSON variable. I'll explain the save state in just a moment. Moving on to our loadGame method, we create a local variable called path, once again passing in both our persistent data path and our save file name, creating a local byte array of SaveJSON, which is set to file read all bytes, passing in the path, and then we set the save variable to what is returned using serialization utility.deserializeValue with a type of save data, passing our SaveJSON local variable and setting the data format to JSON. Our current floor variable is then set the save floor variable, followed by using an if statement to check if the active scene's name is not dungeon, which will use SceneManagers.loadScene, passing in dungeon. Else, a new local variable scene state is created, which is set to whatever is returned by using save.scenes.find, looping through every single available scenes and checking if their floor number matches the current floor. If the scene state is not null, it then proceeds to load the state, passing in the scene state. Else, it uses debug.logError, informing us that there's no saved data for the floor. The delete save method is pretty simple. It gets the path as usual before using file.delete and passing in the path, which will get rid of our save file. There are two of our helper methods, add scene and update scene, which both take in a scene state, with add scene using an arrow function to add the scene state to save's list of scenes. Meanwhile, with the update scene, it sets one of the scenes within the scenes variable within our save variable, making sure to pass in the index, which would be current floor -1, to equal the scene state. As mentioned earlier, we have two other methods, they being SaveState and LoadState, with SaveState returning a scene state, which uses an arrow function, new scene state, passing in the current floor, the GameManager's instance.SaveState, and the MapManager's.instance.SaveState. with the load state taking in a scene state to call MapManager's.instance load state and also the GameManager's.instance load state, passing into those load states their own separate states contained within the scene state. Now opening up our main menu script, we'll be using 4 imports: UniEngine, UniEngine.SceneManagement, UniEngine.UI, and UniEngine event systems. You'll have 2 variables, a private event system called event system and a private button called continue button. We'll make use of the start method. You use an if statement that calls SaveManager's has save available method, checking if the boolean returned is false, which will set the continue button interactable to false. Else, you use the event system variable to call setSelectedGameObject, passing in the continue button.gameObject. We then have 3 methods: new game, continue game, and quit game, all of which are public voids, with new game, which uses an if statement to call SaveManager's has save available, which upon returning true, will call SaveManager's delete save method. It will then set SaveManager's current floor variable to 1 before calling SaveManager's load scene, passing in dungeon, and both continue game and quit game being pretty straightforward. Now opening up the AI class, we're going to create a new public class called AI State. It will have a private string variable called type, providing both a getter, setter, and constructor with a string parameter called type with a default empty string. We slap on a system.serializable, followed by adding a public virtual AI state save state method to the end of our AI class. Open the confuse enemy script. Create a public class called confuseState, which inherits the AI state. The class will contain 2 private variables, a string called previous AI, and an int called turns remaining. Their getters and setters, followed by a constructor whose parameters are a string called type, an AI called previous AI, and an int called turns remaining. Each parameter has its default set accordingly. The constructor uses the base AI state to handle our type string before adding a system.serializable to the top of our confused state. Within our confused enemy class, we add 2 methods. The first is an override method for the save state method. We use an arrow function to create a new confused state, passing in a confused enemy string for the type, and confuse enemy's previous AI and turns remaining. The second is a public void load state that takes in a confused state, which we named state. We use an if statement to check if the state's previous AI is hostile enemy, setting the previous AI to it if true, using getComponent hostile enemy. We then set the confused enemy's turn remaining to the states. Now quickly opening the hostile enemy script, add a public override save state to clarify that the AI type is hostile enemy during serialization. Onwards to our entity script, we create a public class called EntityState. We give it an entity type enum to differentiate entities in both serialization and de-serialization, 5 variables, entity type, a string called name, 2 booleans, blocks movement and is visible, followed by a vector3 position. As always, give them getters and setters, and a constructor that takes in each variable. We add a system.serializable to the top of entity states and head on up. While creating part 10, I changed how I handle the add to GameManager method. So we add in a virtual keyword to the method, an if statement that checks for the player component, calling GameManager's insert entity method if true, else it calls its add entity method instead. Throw in a public virtual save state method that returns an entity state, and open our actor script. We're going to create a new actor state class that inherits the entity state, give it 3 variables, a boolean called isAlive, an AI state called current AI, and a fighter state called fighter state, providing them both getters and setters. We also create a constructor that takes in each variable that also makes use of the base AI states constructor. Scrolling to the top, we're going to add a new fighter variable called fighter and another if statement to check if we have the fighter component attached in the onValidate method. Next, create a new public override void add to GameManager method, which uses the base add to GameManager method, and copy and paste in our if statement above in the start method. We're going to exchange our algorithm equals new atom visibility and update field of view with a new if statement and else if statement, where we check to see if the actor is alive, which would call our algorithm equals new atom visibility and update the field of view. Else, if it isn't alive, it checks to see if the fighter is not equal to null, which will call the fighter's die method. You will notice that die is currently sending an error. That's due to it being a private method, but we'll get back to it. Scrolling down, we add in a public override save state method, which returns an entity state, and a public void load state, which we pass into an actor state. Now, starting with the save state, we use an arrow function to create a new actor state using the actor state's constructor. which would pass into the name of the object, if it blocks movement or not, if it's alive, if it's visible by checking MapManager's visible tiles, which currently passes an error due to there not being a getter for the visible tiles, and passing in the vector-free int position of the entity to it. Then passing in the transform.position and checking if AI is not equal to null, which if true calls AI.saveState, otherwise it sets it to null. We then check if the fighter variable is not equal to null, which if true calls fighter's saveState method, else it sets it to null. In our load state method, and using the actor state provided, we set the transform position of the entity to the state's position. Its isAlive boolean to the state's isAlive boolean. We then use an if statement to check if the entity isn't alive, whereupon we remove the actor from the game manager, followed by another if statement, which checks to see if the isVisible variable within our state is set to false. If that's true, it uses getComponentSpriteRenderer.enabled and sets it to false. Another if statement is then used to check if the current AI is not equal to null. If true, it checks to see which type it is, getting the component of said type and setting the AI to it. If the type of the AI equals hostile enemy, then it simply sets the AI using getComponentHostileEnemy. Else, if the type is confused enemy, it adds a new component, confused enemy, to the game object, setting the AI to it, before creating a new confused state using state.currentAI as confused state and casting our AI variable so we can access the confused enemy load state method, passing in our confused state. Lastly, we use another if statement to check if the state.fighterState is not equal to null, which if true calls fighters.loadState, passing the state.fighterState. Opening the item script, so we can start method to use an arrow function, so it's a one-liner. We're going to create a new item state which inherits the entity state, giving it a string variable called parent, providing both a getter and setter for it, and a constructor, which, like the actor state constructor, makes use of the base entity states constructor. We add in, as usual, two methods, a save state and a load state, the save state being an override for the virtual, which uses an arrow function to get a new item state, passing in name, blocks movement, checking to see if the visible tiles contains our vector-free int position, the transform.position, and it checks that the transform.parent is not equal to null, setting parent to the transform.parent.gameObject's name, otherwise it sets it to a blank string if false. In our load method, it uses the item state parameter to check if the state.isVisible is false, setting using getComponentSpriteRenderer.enable, turning off the sprite renderer in our game object if so. If the state.parent variable is not equal to a blank string, then it creates a game object parent local variable, which equals gameObject.find, passing our state.parent string, which then uses the parent's .getComponent inventory calling .add, a method that we're passing in this script. Add is a new method that we'll get to soon. We then set the transform.position to the state's position. Now open the consumable script, we're going to add another line of code to it, which calls the GameManager's remove entity, passing in getComponent item. Opening the fighter script, we're going to change the seal declaration to a public one. Navigating to our die script, we're going to change it to public. We're going to add a new if statement to it, which checks to see if the actor entity is alive, and once going through the normal process, is going to set the actor's isAlive variable to false. We're going to remove the unnecessary getComponentActor.isAlive variable before scrolling down. We're going to create a new public fighter state class, which holds 5 variables, 4 of them being ints, max HP, HP, defense, and power, and a single string called target, providing them getters and setters, and a constructor that takes in all its variables. Scrolling up, we had 2 methods, a save state that returns a fighter state, which uses an arrow function to get a new fighter state, passing in our max HP, HP, defense, power, and checking if the target is not equal to null. If true, it sets it to a target name, otherwise it sets it to null. Second, the load state method that uses the fighter state to set the 4 int variables of the fighter class to those of the fighter state's int variable, before making a call to the GameManager's.actors variable, which uses the find method to check to see if any of the names within the actors list is that of the state.targets, setting the target to it. Opening the inventory, As informed earlier, we're going to create a public void add method that takes in an item. It uses items.add to add the item to the items list, using item.transform.setParent, passing in the transform of the item's game object, before making a final call to the GameManager to remove the entity, passing in the item. Now open action, we're going to exchange these two lines, item.transform.setParent and actor.inventory, to actor.inventory.add, passing in the item, while also removing GameManager.instance remove entity. Heading into the GameManager script, we're going to import UniEngine.cManagement, navigate to the bottom. We're going to create a public class GameState, which has a private list entity state called entities, getter and setter for it, and a constructor that takes in the list entity state. Going back to the top, we're going to make use of the SceneManager, subscribing to onSceneLoaded, which is SceneManager.sceneLoaded plus or equals onSceneLoaded, which allows us to use the onSceneLoaded method, which creates a local scene state using SaveManager instance save.scenes.find method, which loops through the scenes variable, checking to see if a floor number matches the SaveManager instance current floor variable. We then use an if statement to check if the scene state is not null, which calls the load state method, passing in sceneState.gameState, else it initializes entities and actors. Scrolling up, just going to remove the initialization. And scrolling to add entity, we're going to add in the new insert entity method that we talked about earlier, which, much like the add entity method, it checks if the game object is not active before setting it to true, and then inserting it into the entities list. Finally, navigating, we're going to add in three methods called SaveState, LoadState, and LoadEntityStates. The SaveState method returning a game state, which uses a for each to cycle through every single item within the player's inventory, checking if the entity list contains said item, which, if so, will continue the loop, else it will call the add entity method, passing in the item. This is followed by creating a game state called gameState, which will equal a new game state, passing in entities.convertAll, and using X to loop through every single entity, calling SaveState. We then use a new for each to cycle through every single item within the inventory items list, calling remove entity, passing in the item, before returning the game state variable. In the LoadState method, which takes in a game state called state, we first set the isPlayerTurn boolean to false, which prevents the player from moving during the load. We use an if statement to check if the entities list.count is greater than 0. If so, it uses a for each to go through every single entity, destroying its game object, before clearing both the entities and actors lists. We then use the start coroutine method, passing in load entity states, along with our state.entities. The loadEntityStates method is a private method that takes in a list of entity states called entity states. It creates a local int variable called entity state, which is set to 0, and then uses a while loop with its condition being entity state is less than entity states.count. We use uReturn new wait for end of frame before creating a local string variable called entity name, which uses a ternary with its condition being entity states, passing in entity state as the index.name.contains remains of. If this is true, entity name equals entity states passing in entity state.name.substring, and within the substring we pass in entity states index entity state.name.last index of space +1. If not true, entity name simply equals entity states index of entity state.name. An if condition is then used where if the entity state's index entity state.type equals entity state.entitytype.actor, a local actor state called actor state is created with the entity state as an actor state. We then create a local actor variable with MapManager.instance.createEntity, passing in the entity name, actorState.position, and using .getComponentActor before loading the actor state. Else, if the entity state.type equals entity state.entitytype.item, an item state is created with that entity state as an item state. Before creating an item, using once again MapManagers.instance.createEntity, passing the entity name, itemState.position, .getComponentItem for loading the item state. We then increment item state, which will continue the process until entity state equals entity states.count. The isPlayerTurn boolean is then set to true, which allows the player to move. Heading on over to the TileData class, we're going to add in a new private string called name, its getter and setter, and then we're going to create a constructor which takes in every single variable before going to the MapManager script. Starting from the bottom, we're going to create a MapState class. which will hold a private dictionary of a vector3 tile data called stored tiles, a list of rectangular room called stored rooms, their getters and setters, and a constructor that takes in both the dictionary and list. Our stored tiles will be set using tiles.toDictionary, making sure to import system.link, which will cycle through every single key within the tiles dictionary, casting every single key to a vector3 in the process, while our stored rooms are just set to rooms. Going to the top, we're going to import UniEngine.SceneManagement, remove all initializations from rooms, visible tiles, and tiles, creating a getter for visible tiles. Before, like GameManager, we're going to subscribe to onSceneLoaded, a method that will use to create a scene state variable called scene state, which we'll find using SaveManager.instance.save.scenes.find, looping through all available scenes, checking to see if their floor number matches the SaveManager.instance.currentFloor. We then use an if statement to check that the scene state is not null, calling load state, passing in our scene state.mapState, else we call generateDungeon, a method that, cutting out our code here, we'll initialize our rooms, tiles, and visible tiles, followed by generating our dungeon as per normal, before moving to the create entity method and refactoring what we're using here. So you may notice that a lot of this code is just duplications of one another. So what we're going to do is make use of string interpolation to cut it down to creating a local game object called entity object, instantiating the said game object, passing in our entity string using string interpolation, a new vector3, our position, and the identity, before renaming the entity object to the entity string and returning it, making sure that it returns a game object and not a void. Scrolling down, we're going to be making use of our TileData constructor with name echoing tilemap.getTile return.name, and is explored and is visible set to false. Going down to set up FogMap, within our for each statement, we're going to add a new if statement setting that tile's alpha to half, else it sets it to 1. Adding in the two state methods with our public save state returning a map state, which uses an arrow function to return a new map state, passing in tiles and rooms, before finally our load state taking in a map state. It will set our rooms variable to the map state stored rooms and tiles to our map state's stored tiles, which will use the toDictionary method to cycle through every key within our stored tiles dictionary. Our tiles will equal our map state stored tiles, but it'll call toDictionary, so it cycles through every single individual tile, casting it to a vector3 int with the value remaining the same. An if statement is then used to check if the visible tiles.count is greater than 0, clearing it if so, before using a for each to cycle through every single tile key, checking if the name equals floor tile, calling floor map.setTile if so, else if the tile name equals a wall tile, you'll then call obstacle map.setTile otherwise, before calling setup fogmap. Opening the UIManager, scroll down, we're going to be adding a new escape menu UI. So we're going to add in a header attribute called escape menu UI and a new boolean called isEscapeMenuOpen, setting it to false by default, and a new game object called escape menu, providing the boolean its own getter before scrolling down. Here we're going to create a new public void method called toggleEscapeMenu. It works the same as the other toggle menus, but in our if statement, it uses our event system variables set selected game object, passing our escape menu's child game object. Going to the toggle menu method, we're going to refactor all our if statements with a switch case. The switch case will go through every single menu boolean, checking which one is true, calling it in the process. Finally, going to just below toggle escape menu, we're going to add in 3 new methods, save, load, and quit. However, with the load method, not only will call load game from the SaveManager, it will also call toggle menu. This is due to the fact that we don't want the menu open if we loaded the game while in a scene. Open the player script, and within the onExit method, we're going to add a new if statement that checks if the UIManager's isEscapeMenuOpen is set to false, and if the UIManager's isMenuOpen is set to false, calling its toggleEscape method if so. And as we don't want 2 calls, we're going to set the if statement after to an else if. Opening Unity to back up, within the floor 1 scene, we're going to go ahead and expand the canvas game object, drag in the event system, before creating a new game object that's going to be centered in our canvas. Expand that just a bit. Set as color black. rename it to escape menu. We're going to give it a button child object. Remove the button's image, call it return to game, setting its anchor to top. We're going to expand the button within the hierarchy, rename the text to return to game, its font asset to Roboto, selecting auto size, make it bold, and change the vertex color to white. Returning to the button, we're going to drag in our text game object into target graphic, adding a new listener to on-click, dragging in our canvas. Clicking the drop-down menu, we're going to hover over UIManager and select Toggle Menu. Duplicate it 3 more times, positioning it as you do. Rename the first duplicate to Load Game. The second to Save Game. And the last to Exit. Returning to Load Game, we're going to set in the drop-down menu, instead of calling UIManager's Toggle Menu, we're going to instead call Load. Repeat this process for the other buttons. Color them if you wish. Now selecting the canvas game object, we're going to scroll down and drag in the escape menu game object into our escape menu variable. Scroll up and selecting overrides, we're going to apply all. Making sure that escape menu is also turned off when doing so, before proceeding to our main menu scene. All right, with our main menu open, we're going to go ahead and import whatever landscape image that you want to see to represent your main menu. I've opted for a nice dark background with a face, but you can generally do whatever you want. From there, we'll create a SaveManager game object, adding the component SaveManager. Next, we're going to create a new canvas, setting the render mode to camera, the UI scale mode to scale screen size, the reference resolution to 1920 by 1080, and height to 1. Add the component main menu. And before we set the main menu's variables, we need to first create a continue button. So first, we're going to create an image child object for the canvas, name it background, setting it to the image that you imported, with its anchor to stretch. Create a new text mesh pro game object called title. You can position it however you want. And finally, a panel. I'll just call it menu panel. I'm going to set the anchor to middle right. Now, within this panel, we're going to create 3 buttons. The first being play a new game. The second, continue last game. And the last, quit. With our buttons created, we're going to add listeners to them. So plus, we're going to drag in the canvas object, selecting the drop-down menu, hover over main menu, and press new game. Continue for the rest. Now selecting canvas, we're going to drag in our event system into our event system variable for main menu and the continue button. Now just before we click play, we're going to select event system and replace the import system and play. Our continue button's been disabled since there is no save, so we can go ahead and press play. And saving here. And loading. Now let's test it from the main menu. Our continue button is not disabled, so we can go ahead and click that. And it loads the game perfectly fine. If you enjoyed, consider liking the video, comment if you have any questions, and subscribe to the channel. Cheers.